So here I'm with John Peterson, who's an old friend of mine and actually a pretty important person in the internet. And we thought we'd, and so we thought it'd be good to sort of ask John a bit about what's going on today, some particularly interesting topics. But maybe we should start with, so how did you get involved in internet governance?
That's a good question. So I was lucky enough to be around in the early dot-com boom in the late 1990s, and a small startup that I worked for in Boston was acquired by Level 3 Communications. They moved me out to scenic Boulder, Colorado, where Phil actually was as well at roughly the same time. And Level 3, of course, is one of the Tier 1 backbone providers of the internet. And they have a profound engagement with the Internet Engineering Task Force and with the standards bodies that help to make the internet, to define how the internet works. And when I got there, that was one of the things actually that most attracted me about this opportunity, would be the ability to really work with the top minds who were out there. And so I started attending the ITF. I'd been on mailing lists and things like that beforehand, but I first started attending when I worked at Level 3. And I just found it to be a fascinating community that had such intellectual rigor, that just had so much interest in trying to find the right solution. You don't go to the ITF and represent a company. You go there and you put forward what you think is the best idea, and it's really a place where there is a meritocracy of ideas. And once you get the bug for it, of course, you discover there are all these other dimensions to internet governance. If you're there at the ITF, you may end up dealing with the W3C if you work on applications, as they have responsibility for the standards associated with the World Wide Web, like HTML. You may end up working with ICANN, with the people that do domain name assignments. And I kind of made the rounds of these internet governance circles. And working on the intersection between technology and public policy tends to take you to some pretty interesting places.
Well, so I think some of the first work that you did with SIP, the Session Initiation Protocol. Do you want to talk a little bit about this IP telephony and kind of what that path was and sort of where SIP is today and what your part in it was?
Sure. It's important to remember that in the early 1990s, there really wasn't anything like voice over IP. There were some experimental technologies people had rigged up that worked in some of the Unix environments in labs in California and so on. But there was no commercial product you could buy that would let you talk to somebody else over the internet. Remember as well that, in the mid-1990s, a lot of computers didn't have adequate sound cards, or certainly wasn't adequate video capture. And, network interfaces were spotty at best, and the actual commercial services you could purchase, especially at the consumer level, to get enough bandwidth to communicate over the internet, something like voice over IP, they didn't really exist. So sometime around 1996, 1997, we'd hit a sweet spot where the computing power was there, the network was there, computers tended to have the right interfaces to do this, and so we started to see the first commercial voice over IP offerings around that time. When I started working on this around then, 96, 97, I worked on the infrastructure dimension of this. The startup that I worked for in Boston was focused on the particular problem of how you could take a traditional telephone switch, and these telephone switches made by companies like Nortel and at the time Lucent, they were enormous, expensive, monolithic, special-purpose devices that required a ton of operational oversight. It didn't really fit into the internet software model or the kind of the internet, disruptive innovation that we all associate with technology today. And so I was one of the first people to work on something called soft switching, the idea that you could just take a general purpose computer, take a Sun box, Unix box, and put the control plane logic for a telephone switch on a box like that, and just have it control telephone resources that actually handled switching literal circuits from one customer to another, to handle those as dumb devices. And this created an extremely disruptive influence on the telephone switch market, and today I think it'd be safe to say that it's become the dominant paradigm, and that you actually can't really buy things like these Nortel switches anymore except on the secondary market. If you own one and you need replacement parts today, you pretty much have to get them on eBay if you need like new line parts and things like that. Now, once you build a soft switch, naturally these Sun boxes or other Unix boxes, they have internet access, and you need to have ways for these switches to talk to one another, to be able to coordinate calls that don't use the outdated X25-based SS7 systems that are used in the traditional telephone network. And that's where tools like SIP started to come into play. So a lot of my early work on the session initiation protocol was on telephony replacement, was on how you would be able to not touch that traditional network, but instead do all of this over the internet to be able to set up calls end to end. And this turned out to be a pretty important dimension of adopting voice over IP protocol. It's one thing to build a tool that lets you talk to anybody else who happened to have a good computer, right, in the 1990s and similar technology that you had, but very different matter to be able to call someone who's actually on the telephone network with a real telephone number. And these soft switches became bridges between the traditional telephone network and people in the voice over IP space. And these have been essential going forward to how voice over IP has become successful, to the ability for programs like, say, Skype today to be able to call out from your PC to someone who has a normal landline black phone.
Also, I think one of the things that you worked on in sort of the more refined versions of SIP was its security model, right? How do you actually secure the signaling protocol? So as I'm sure you can imagine, given sort of some of the recent events in the internet with respect to sort of the Snowden releases, this is sort of an interesting question. Like, what is, I mean, do you see something about the implications of stuff like SIP and security with respect to then PSTN, like wiretapping laws, all those kinds of questions? Like, where do you think this is going, or how is it different?
Wow, big question. Yeah, so I do recall when we were building the RFC for SIP, RFC 3261, we basically kind of drew straws for who was going to do what parts. You know, I got to write the little overview of how SIP operated, a little one-paragraph statement. I got to do addressing. I got to do user agent behavior, and then I drew the straw to do security. And I was like, oh, okay, I have a bit of a security background. This shouldn't be too difficult. And the initial planned one section on security in SIP actually ended up being 4 chapters of the RFC. And at the time, this was the largest RFC ever published, and SIP did not come out then. And SIP security has always been a problem child. And these revelations obviously have put the IETF and the people who develop standards in a very interesting position. You know, no less an authority than Bruce Schneier, who I would say is one of the greatest minds thinking today about security, has formally called on the IETF to drop what it's doing and to refocus all of its efforts in our upcoming meeting, which will be in Vancouver this November, on how we're going to resolve the problems that have been raised by PRISM. And you know, we've studied the privacy properties of these protocols and the security properties of these protocols very extensively. I'm as convinced now, I think, as I ever was, that we made a lot of compromises in the design of SIP security because they were necessary for it to be adopted in the marketplace. It would be great to be able to design a protocol that had end-to-end security that can guarantee integrity and confidentiality between one endpoint that's trying to make a call and another endpoint that's trying to make a call. As soon as intermediaries are playing some role in the delivery of that, as soon as they need to help you to find the right endpoint, and this dynamic capability that SIP has to allow, you know, if I wanted to have 5 devices that would all register under my SIP name, a desk phone, a cell phone, my iPad, various other devices, they all need to register to some server that lives in the network somewhere that's going to be responsible for routing traffic to it. The degree to which that server has access to signaling, has access to who's calling me, and, you know, what are the media streams that are going to be set up, and what are the IP endpoints that media is going to be sent between. We could have done more to protect that when we designed SIP, and I think if we had, we wouldn't be talking about SIP right now, because it wouldn't have succeeded enough for it to even be noteworthy.
Also, what are some, can you talk a little bit about, so SIP might be a protocol that most people don't realize that they're using or where it's being used. You want to talk a little about where it's been successful and where it's been really adopted?
Sure. So I mentioned Skype. If you do Skype in or Skype out, typically that is Skype's internal protocols converted into SIP for transfer to a gateway, which would then go to the telephone network. Basically, if you use a voice over IP service for a landline in your house that comes from either FiOS or from a cable provider. That's surely SIP that is being used in the background. The third generation cell phones, things that are 3GPP based, all use SIP signaling inside them. Now, I mean, these networks, especially when we talk about mobile phones and about the networks we see and the cable MSOs and so on, they use a version of SIP that is relatively architecturally similar to the telephone network. They kind of apply the protocol machinery of SIP to generating a system that has many of the same properties that the telephone network has. And this too it's a fundamental trade-off in the design of these things. I would love to see a SIP that was much less dependent on the network elements shaping traffic and deciding how, that it was much more driven by the endpoints. This is just kind of a fundamental end-to-end principle of the internet, that you want to have the smarts be on the endpoints. You don't want to have an intermediary in the middle need to understand what endpoints want to do. It shouldn't get in their way. It shouldn't prevent them from negotiating. If I made up a great new codec tomorrow and I have a copy of it and you have a copy of it that sits on our two machines, I don't want that thing in the middle of the network to have to know anything about that codec to let us connect and to use it. The realities, though, of how these things actually get implemented, especially when you're doing something as complex as replacing the telephone network, replacing a more than a century-old system with its reliability constraints, with its emergency services implications, the ability to call 911, just getting the basic services people associate with this right. It requires you to make compromises, and I can't say I'm always proud in retrospect of the compromises we needed to make in order for this to be successful, but I do acknowledge in retrospect that if we had pushed back on some of those compromises, it certainly would have led to the death of the protocol. And as people who design standards, this is a heartbreaking thing that you come up against again and again. Now, we can be smarter about this, and I think if there's a silver lining to these increasingly disturbing revelations that are coming up about widespread state surveillance of the internet, it may create a political will to see a change in what we can get consensus for, and hopefully in what people will be willing to deploy. I believe when you go to the ITF, since it is consensus-based, there are things we could get consensus to do that I think would be very radical at this point, because the people who go to the ITF are so well informed, they're so energized, they're so interested in individual liberties. I would hate to see the ITF, though, become an organization that is developing standards that never see the light of day because it has swung too far in this direction. And so it's very difficult for us to understand what the right course is for us to chart at this point.
Interesting. Well, so I'd like to wind back a little bit, where you mentioned about how building sort of the first soft switch where devices and all the logic was in the general purpose computer. At that point, pretty hardened sort of sandbox. But do you see a parallel between that and then software-defined networking today, where we see that transition maybe happening in the internet and sort of some of the momentum that's occurring behind SDN?
I mean, I certainly see many parallels there. I'm not sure those parallels will play out in exactly the same way, because the companies like Cisco and Juniper that would stand to be disrupted by this, the way that, say, Nortel and Lucent were in the 90s, they are more agile companies. They are companies that are taking these technologies and trying to figure out a middle path, I guess. For example, there is the I2RS, the interface to the routing system, standard proposal circulating in the ITF now. It's a bit different than the very low-layer software-defined networking approach that we see, say, in the Open Networking Foundation, but it's nonetheless a way that software can interact with the FIB and to help higher-level routing decisions get made. And I think the routing vendors view this as one tool among many that will help decide how packets are going to be forwarded. They're figuring out ways, in other words, to subsume this that will allow their device to take advantage of the strengths of this without necessarily eroding the market control and the lengthy install base they have of maintenance tools and so on that have proven so successful with the internet in the past. And I don't know that core routers have, to the degree that old telephone switches did, impeded innovation in the network as well. And that was another real driver for doing soft switching was that these traditional telephone switches were so monolithic. They had no programmability. There were no realistic interfaces that you could use to alter their behavior without doing open heart surgery. The situation is very different, I think, for core routers. But the parallels, I mean, they do stand. I certainly wouldn't dismiss it out of hand. And I certainly know people who work for major router vendors who, if you find them at the bar at the right hour, will cry on your shoulder about exactly, their concerns about this. And it is a real challenge for that business.
Interesting. Well, so if we were to look at all the different pieces of work, I mean, so how many working groups are in the IETF today?
Off the top of my head, I'm not sure I could say.
60
order 100, yeah.
Well, so if you were to sort of think, what's the sort of suggest to somebody, hey, this is maybe something you should keep your eye on, is what I think is some of the most interesting work going on the internet, sort of stuff which is currently in progress and might really significantly change what the network's like in 3 or so years. Where would you suggest looking?
Well, actually, that I2RS group would be a very significant one that I point to right now. There is a new effort that's just been spun up. It's unclear if it's going to be a working group or not. That's called PRPAS, which is the IETF's forum for discussing PRISM and for discussing how these security things are going to be addressed. There are already some proposals that are circulating there that are really about structural changes to how the IETF process would work. Should standards have to meet a new bar, basically, in order to obviate the very real concerns that are increasingly coming to light about all of this. If you were coming to Vancouver this time, these are two things I'd certainly come you to. There are things I personally happen to be working on I think are very interesting and impactful that might not ascend to exactly that level, but I continue to be very interested in CDNs and the degree of internet traffic that is now being directed by content distribution networks. We're doing a lot of work today on interfaces for understanding how CDNs can express their coverage areas and how CDNs can advertise services that they provide in order to allow collaboration or clearinghouses among CDNs to make more optimal selections of CDNs. I think this will have potentially a tremendous impact on the efficiency of internet traffic, will alleviate some of the bottlenecks that people predict as more and more video moves onto the internet. That's a personal pet project of mine. And I am also still working on some things related to the intersection of the telephone network and the internet. One thing that's been, I think, a major issue, robocalling has become an increasing problem as the internet and the telephone network have become more interconnected. And right now I'm looking at ways that perhaps we can do better identity services. So it's harder to spoof calls. It's easier to find out who's responsible for a telephone call that's coming off the internet before it hits the PSTN. As the numbers for this are just going up and up and up, the FTC and the FCC are profoundly interested in finding a solution for this. This is work that is being discussed in congressional subcommittees already as it's going on in the IETF. So that's another place where I think we can really make a difference. And something that is hurting consumers and will be a big deal going forward.
So if we stop receiving robocalls, then we have you to thank.
Right.
Great. Well, thanks for coming by. Thanks for your time. And,
No, my pleasure.
yeah. Thank you.
Bye.